Hi guys, my name is Mike, and in this section we will discuss Fluence services and Fluence Compute Engine. In particular, the agenda of this section is as follows. First of all, we will start with a little introduction to WebAssembly, just a couple of slides. Then we will walk through some Fluence services internals and FC runtime. And finally, I will show you how to develop and debug a simple whole world service for the Fluence network from scratch. Let's start with answering to the simple question. What is WebAssembly? Actually, I have taken this marvelous slide from the Ben's Meet talk on SPPCon 2019. You can find the link at the bottom of the slide. And here we can see the directed graph. And moving from left to right, we can construct our own definition. What is WebAssembly? I ended with this one. So, WebAssembly is the open standard of stack-based virtual machine that has different parts, such as stack, tables, global variables, linear memories, and so on. And the WebAssembly specifications introduce concept of modules with imports and exports. A WebAssembly modules could be considered as a black boxes whose exports contains entry points that define how exactly it could be called from some external world, for example from a browser or operation system. And imports define which functions from external world a module could call. And also it's important that WebAssembly specification defines only primitive types. By primitive I mean that there are only integers and floating point numbers. For example, there are no any arrays, strings, records, and so on. Just these types. And of course this makes it difficult to make handy API and ABI of modules. But WebAssembly provides us a way to abstract these constraints with help of interface types. On the slide you can see a complex scheme where on the middle this blue box represents a raw WebAssembly module with raw imports and exports. So by raw import and export I mean that this function could operate with only primitive types, with only floating point and integers. And this adapted module could wrap this raw module and provide some adapted import and adapted export that could lowering and lifting types between complex and raw types. So half of work by type conversion could be done by module itself. And the another gem of WebAssembly world is WASI. WASI stands for WebAssembly System Interface. So it is standard of POSIX-like imports that a module could call from runtime. And on the slide you can see the compilation of two Hello World program written on Rust and C++. And actually this gives WebAssembly binary with the same imports thanks to WASI. So here we can see 5 imports. Yep, and WebAssembly provides us a way with help of WASI and help of modules with imports and exports to make heterogeneous runtime that could run modules written on different languages. So, but actually at the moment we provide SDK only for Rust. So Rust is our primary language for backend service developing. And I think that it's right time to dig into the details of this SDK and the service internals. So Fluence service is a group of modules linked together by shared nothing linking scheme. So this linking scheme is based on linking only imports and exports of modules. This means that all module state keep in private. For example, WebAssembly module doesn't expose memory, tables, globals, and so on. And all of this is possible because we use interface types, and each module contains adapter functions that could lowering and lifting types. And also with help of interface types, our module keep its states in private and linked together only by imports and exports. Actually, we have three types of modules. The first one called facade. So this module actually exposes the API of entire service. So in each service there could be only one such module. Next one is pure modules. Pure modules could contain all business logic, and they can't access file system or call external binaries. And last one called effectors, and the purpose is to do some stuff related to file system, other operation system services, or calling external binaries. And also each service should have a configuration file. On the slide you can see the example of configuration file for URL downloader service. You can find also the full code of the service by the link in the bottom. This service consists of three modules. The first one called local storage. As you can see, it is a factor because it requires access to file systems through WASI. So in particular, it requires access to a directory called sites. Here pre-opened files is a list of directories of files that a module could access during its work. And mapped dirs here could be used for setting aliases for each pre-opened files. The next one is also a factor because it requires access to mounted binary called curl. So here this mounted binary option says that a module could call a binary located by this path. Here is a user bin curl on file system. And the last one is always facade model that exposes API of an entire service. And on the slide you can see principal scheme of Fluence Compute Engine. So Fluence Compute Engine allows to load several services on the same moment, and each service could consist of several modules, as we discussed. So the module, these modules link together by import and exports, and effectors modules of each service could access some operation system services with help of WASI. And also, as you heard on previous slides, Aquamarine is our language based on p-calculus for complex multi-agent scenarios across the Fluence network. But what is the connection between FC and Aquamarine? So actually, Aquamarine interpreter is compiled to WebAssembly and could be loaded to FC runtime as a module. But this module have a special property that allows the interpreter to call other services that are loaded to FC at the moment by special instruction called call. So you can find more information about Aquamarine on next sections, and also in our doc. And finally, let's consider how services for Fluence could be built and debugged. All complexity of generation WebAssembly binary and generation and compiling interface types is encapsulated in our SDK and building tools. On the slide you can see how Hello World for Fluence could look like. So this example contains two functions, main and greeting. And the first one is needed for initialization of WASI. So it's called only once on the module startup. The second one, greeting, is wrapped by our special procedure macro FC, and this makes this function exported from a module and allows other modules or Aquamarine scripts call it. So as you see, you can find the complete example of the service by the link on the bottom of the slide. So this FC macro could be applied to function, external block, and structures. So applying to functions, as we saw on the previous slide, makes this function export from module. Applying to external block tells our building tools that a module requires imports from such module. For example, in this case, it's curl adapter. And the last one option provides a way to use structure types in signature of imported and exported function. So in first and second variants. Finally, in this section we discussed FC and our Rust SDK a little bit, and you can find a repository for them by these links. And also we have documentation about module developing that could be found by this link. And so on the next, we will take some hand-on section with developing a simple Hello World Fluence service. Let's see how simple Hello World module could be built for Fluence and then could be turned to a service. But first of all, we need to install Rust and also implementary tool, and then install our build tool and tool for debugging. So actually you can find all comments on our docs. The link was on the previous, on the last slide. So actually also I have all this tool installed on my setup. On your it could take more time, of course. And also please note that it's important to install nightly Rust, because our repo requires only nightly toolchain of Rust. So then let's install Wasm32 WASI target. It could be done by this command. So for me it's already installed. Then we need to install our building tool. It's called FCLI. So this command adds binary code FC to your system, and then we also need to install a repo that could be used for debugging, and it is. So we installed Rust Wasm32 WASI target for Rust and our building and debug tools. And actually here we could create a new project. So with Rust it could be done by cargo new, let's call it greeting, and make it binary. So here binary means that final WebAssembly binary will contain some initialization code for WASI. So it's important to make it binary. So okay, and then let's edit a little bit cargo toml to make it compile to WebAssembly. So, and to specify our Fluence SDK. So actually let's change it into some, for example, something like this one, and also let's add our SDK as a dependency. Actually its current version is 2.17, but it doesn't matter for our example. We could use the last one. So let's save it and exit, and then let's open our greeting RSRC and main, the main project, main RSRC file. And so here we need to include our macro. So it could be done by this. And then we need to leave main empty. So, and then we could run our main function that wrapped with FC. So let's follow the example that was on slides. So let's call this function like greeting that takes as string and return a new string. And internally it could, for example, append to string something like this. Yep. So, and it is. And actually it is all code for simple hello world. There are only two functions, main for initializing quasi and greeting as main export functions. So it is. And then we need to compile this. Compiling is done by our FCE, so we could compile it by FCE build. It just a wrapper on Cargo that could embed interface types. So after compiling, it takes some time, different on the cache of compiled Cargo artifacts. Also FCE allow you to for example, find out what interface types is generated. For example, let's see for our case, because we haven't specified release, so it's should locate it in debug folder. So, and here we can see generated interface types for our simple binary. So then let's convert it to a service. To convert to this binary, this module to a service, we need to do only one thing. So actually we need to write a config. Yep. Let's create a new config toml and so just write something like this. So here we specify that binaries for this service is located on this folder. It's called artifact, and the service is consists only on one module called greeting, and it is. So that's all. Let's save it. So we successfully created a new service greeting, and then let's see how it could be called. Actually, there are several ways to call it. One way is to upload it to Node and then call it with Aquamarine or something like that. But for debugging purposes, we have a special tool called REPL. But first of all, we need to create artifact folders and then copy our greeting binaries to it. So something like that. Then we could run fc REPL and specify our config toml to it. Actually, REPL supports several commands for loading, unloading modules, calling, obtaining their interfaces, environment variables, file system state, and so on. But today, for us, important to call module and see the result of calling. So calling module should be done with specifying module name, in our case it's greeting, export function name, in our case it's also called greeting, and arguments. And arguments should be encoded in JSON. So it could look like this. And let us see something like John. And here we see that the result is a hi John. Yep. It's the same string that we expected. So thank you very much. On this my section is done. On next section you will see how more complex services could be built, then how they could be deployed to Fluence network and called by Aquamarine. Thank you.
Hello, my name is Dmitry. I'm a software developer in Fluence. Let's continue our journey to the Fluence system. I hope that you already saw previous videos of our speech series. Today I'll show you some tips and tricks on how to build services in the Fluence network. I'll take services that we used in Fluence Spite project, for example. To start the creation of our service, we simply initialize our Rust project and add Fluence library to dependencies, as you see on the screen. First of all, we want to initialize our fresh services in service lifecycle. It could be logger initialization, as you see on the screen, or creating a database, or initialization some preloaded data, and we use the main method for this. So how to build functions that we could call from AR script? As Michael already said, we need to mark our functions with FCE tag. FCE environment doesn't support result types as a result, so we need to wrap possible errors in structure. For this, we create custom structures, as you see on the screen, with a return code to understand if it is an error or a successful result for every function, and convert results to these structures for the convenience of application development. And this is code for conversion. So in our methods, we just use into and convert our simple functions that return result to our structures. And to use the structures from AirScript, we mark them with the FCE tag as well. This project is quite simple. We just add some data to our storage and return it if needed. For this, we have a join function to add user to database to some sort of storage, leave user to delete user from our storage, and some helper functions that we later discuss. In this example, we use in-memory storage that will be cleaned after service will restart, not restart or some other reason. As you see, it's only a hash map to store our data. But if needed, we can connect and use database modules. We have SQLite and Redis as Wasm modules for now, but it is possible to create a proxy modules for every database and other stuff that can use a file system and store data in long-term storage. To connect other modules, we need to describe a P of a module to connect it to your code. For this, we need to write this code. We need to tag our code with FSC tag, write our module name, as you see on the screen, and add functions from this module. If you make a mistake in your code, you'll see it when you compile your Wasm modules in FREPL, as Michael said before, or after deploying, Node will return an error that it cannot create such link of modules. After this, you could simply use these functions in your code, as you see on the screen. To use CLI or maybe some operating system commands, you need to import host functions like this. So main difference is that name of module is host, and here is a CLI tool name, and commands are passed as string. If you want to use file system, you can use it as you would normally do it in Rust, but all this, like file system or other modules or host functions, should be specified in the config that Michael mentioned before. Another important thing that we need to build our services properly is authorization and authentication. First of all, to check if a caller is an owner of a service or it exists in some sort of list, we need to get the caller's ID. This and other useful info could be found in call parameters. Call parameters we could get like this. And what is call parameters? It's all necessary information about caller and about arguments that we pass through our function. It is like init peer ID, service ID, service creator peer ID, host ID, particle ID, and tetraplets. So here in user list, we only need an init peer ID to check. But what if we need to verify into that the user is authorized in other services? So let's have a look in a history service that store our messages, and these messages could add only that users that is authorized in user list service. In user list we have a function that called isAuthenticated, and it return a result of authentication. So if a user is in list or he is an owner of this service, we return true. Otherwise, we return false. So how can we check it in history service? This is our function to add messages, and we have argument called auth that is a boolean. How can we check from this argument that it is a valid info from user service? We check it in isAuthenticated function. So let's have a look. First of all, what we need is get our call parameters, as we seen before, and then we need to check our tetraplets. Tetraplet is a security tetraplet that store necessary data to have a proof of calls. So here we have peer public key, service ID, function name, and JSON path. How can we use it? So tetraplets are vector of vector. First vector is as our list of arguments in function, and second vector is for the case if our argument is a vector and we need to check each element of this vector. So simply we have an index of our argument, and we get tetraplet for our argument, and all that we need that tetraplet for our argument match the specified parameters. As you see, we need to check all fields of our tetraplet with specified parameter and that auth is true. After that, we can be sure that the call is authorized. After we write our code, we can build our services with FCE and upload them via JavaScript SDK. To simplify this process and use simple commands from the terminal, we wrote proto distributor that use JS SDK and could upload modules, create blueprints, and services. Let's have a look on this thing. This command line tool could be found in our GitHub repository. I'll show you how to do this in a few steps. First of all, we can look at the help and use commands to upload our module. With this command, we could upload, for example, user list Wasm file that we will name as user list. So module uploaded successfully, and after this we need to create blueprint in which we list all our modules that we want to use in our service. So it looks like this, command called add blueprint. Here we need to list our dependencies. Here we have only one dependency, but if we want to use maybe SQLite, we need to add this before module that used this module. After that, we need to specify an ID of our blueprint. It could be some custom ID, maybe UUID or something like that. And the name of blueprint. So blueprint usually started successfully. And after that, we need to create service. So here we use blueprint ID to do a calls to a service as an owner. So let's just create our service. And here is our service ID to use in our AIR scripts or in JS SDK. That's all. With these services, we could build big network, big application that will use services from other nodes, services from other providers that can use data storage, local storage, file system, operating system commands, and other stuff. Thank you for watching, and let's move on to the next video.